Good morning, students. Today we are going to see size dependent properties. So before going to this topic, what we saw in the last class means we saw the scaling laws. The scaling law, continuation of the scaling law is size dependent dependence of properties of the nanomaterials. So size dependent property is explained with the help of the gold. I am going to consider a micro level size of the gold. Here the size of the gold is smaller, considering as a size of the gold is considering as a micro level, and at the same height is a smaller cube. So it will be exactly same, okay, same size for entire cube. So it will give the following properties, like it will be yellow color, shiny and heavy. So when I moving to the size will be, when I moving to the nanoscale level, so it will be changing the color as well as the melting point and the chemical properties also. So nano gold does not act as a bulk gold. Next, in the size dependent properties, at nanometer scale, properties become the very important thing because it's a size dependent. Similarly, in the following properties are mechanical properties are examples: adhesion and capillary forces are depending are the dependent. Mechanical properties are dependent on the adhesion and capillary forces. Similarly, chemical properties, reactivity, catalyst. Then chemical properties are melting points. Then electrical properties, tunneling current. Optical properties, absorption, scattering, and magnetic properties are superparametric effect. So these are the properties as example for the size depending upon the size, depending upon the sizes. Okay. Next, surface to volume ratio versus shape. So I am considering the three shapes of the gold. First of all, I consider the not a gold. I am going to consider a nanoparticle. Here sphere, cylinder, cube is the three shapes are here. So when I am going to calculate the A by V, that is nothing but the surface to volume ratio. Here initially for sphere it will be 4 pi r square divided by 4 pi r cube divided by 3. I am getting that 3 by r. Similarly cylinder I am getting that 2 by r, and for cube 6 by l. So here I am getting that A by V is 3 by r for sphere, cylinder for 2 by r, and cube is nothing but the 6 by l. I am going to take as a each side as each side as l equal to 1. Similarly for r equal to 1 as a unit length. So here A by V is for sphere is 3, cylinder is 2, and cube is having 6. So here cube having the large surface to volume ratio, having the larger surface to volume ratio compared to the other two shapes. So it gives the a nanomaterial shape is the greatest interest because of various shapes will produce the distinct surface to volume ratio and therefore distinct properties. That is the very important thing. At the same time, the fraction of the surface atom increases. The fraction of the surface atom, that is a very important point, as the particle size goes down. So when the particle size is going down, the fraction of surface atom will be goes down, when at the same time the fraction of surface atoms are increased. Then surface energy, having the following important points: surface atom possesses more energy than bulk atom. Surface energy possesses the very high amount of energy as compared to the bulk atom. And the surface atom are more chemically reactive. We already saw this because the size dependent properties. It is the size dependent. Nanoparticles are size dependent. So size dependent means it's also chemically reactive. Nanoparticle possess more chemical reactive. Here the simple examples they were given with the help of drawing. Next, we are going to see the intermolecular forces. Before going to intermolecular forces, I am going to see this intramolecular forces also. The intramolecular forces having the following thing: it is a chemical bond and also having the strong relationship, directional and short range relative. So this is the properties are defining the intermolecular forces, but at the same time intermolecular forces having weaker than chemical bonds, okay, usually much weaker, then less directional than covalent bond, less directional than covalent bond, then large range than the covalent bond. So these are the properties having that type is called as the intermolecular forces. Then conductive phases are solid and liquid phases, they will call as the conductive phases. It having the intermolecular forces attracts between molecules then that are in close proximity, okay, that are attraction between the molecules that are in the close proximity. Here liquid and solids, you can see that the attraction between the molecules are very high within the close proximity, Here another examples is examples are given with help of the diagram. Here you can see this is the intermolecular distance. In the solid, the intermolecular distance is only 3 Armstrong, okay, but in the liquid the intermolecular distance is only 5 Armstrong, not for, especially not for in water, but in the gas the intermolecular difference is 30 Armstrong, that value is depend upon the pressure. So these are the simple thing they were given. Then at the same time the intramolecular distance is 1.5 Armstrong at all three things, okay, all three things. Then physical dimensions, here the physical dimension diagram is given, okay, size and dependent properties are, okay, given in the form of circle 1 nanometer to 1 micrometer. Then that will be, they will consider as a nanoscience. Here nanometer, the length scale where corresponding to the corresponding properties is size and shape dependent. The length scale where corresponding property is size and dependent, that is one important point, okay. The length scale, here bore radius is 0.5292 Armstrong, then 0.05 nanometer, here they were given. Then C atom, the C atom is 0.17 nanometer, then 1 nanometer line, 3 C atoms will be there, then 1 into 1 nanometer surfaces, 9 C atoms will be there, that carbon atoms, I think, okay, that carbon atoms, they define carbon atoms. Then 1 nanometer cube, 27 carbon atoms will be there. Then 100 nanometer cubes having 2.7 into 10 power 7 carbon atoms will be available. For 1 meter cube, 2.7 into 10 power 28 carbon atoms will be there. So length scale is here, the defining the length scale, okay. Next, nanosystems with defining with help of this surface system, percentage of surface system. Example, I am going to consider as a gold nanoparticle. Here I am going to take as a sphere of radius. The shape is sphere. The shape dimension is 12.5 nanometer. It contains the 4,80,000 atoms, okay, but the surface is having only 49,000 atoms, so it is only 10%, approximately 10% of atoms will be available in the surface. Then I am going to consider as a sphere of radius at 5 nanometer. Here this one is very less diameter as compared to the previous one. It contains the 32,000 atoms, but here you can see this, here the surface contains approximately 80,000 atoms, so approximately 25% of atoms are the surfaces. So surface atoms have unused electrons, so very reactive, it can be used for the catalyst. Here you can see the optical properties. So first initially I am going with explaining with help of the color of the gold. So I am going to consider the bulk gold. Normally it has a yellow color, appears as a yellow color, but when I am moving to the nano sized gold, it appears it should be a red in color. The properties are so small that the electrons are not free to move about as in bulk, because this movement is restricted. Here it has the large surface, or it will be large. Due to that, whatever the electron will be, the movement of the atoms are sometimes electrons, not atoms. Electrons will be movement will be very, so the color will be varying, but it is a smaller one. So the movement is restricted. The particle react differently with the light. 12 nanometer. This is a simple example of 12 nanometer gold cluster of particle. It's look like a red. Next, melting point of substance. Melting points of a substance. Here I am going to the temperature at which the atoms, ions, or molecules in a substance have enough energy to overcome these intermolecular forces that hold them in a fixed position in solid. Okay, this is the important point. Okay, the temperature at which the atoms, ions, or molecules in a substance have enough energy to overcome intermolecular forces that hold them in a fixed position in a like a solid. Okay, here they were given in contact with the atoms. Here they contact with the 7 atoms. The one is contact with the 1, 2, 3, 4, 5, 6, 7. This one is contact with the 7 atom, but this one is contacted with only these 3 atoms. Okay, surface atom requires less energy move because they are in contact fewer atoms of this substance. Next, understanding of melting points with the help of the macro versus nano. Here I consider the macro. The majority of the atoms are almost on the inside of the objects. Here you can see the majority of the atoms are available inside in the outer surface. Only less amount of atoms will be there, but here split between the inside and other surface of the object. Here you can see this. Here you can see this splitted with here the number of atoms are very less, but at the same time the more number of atoms are available at the surfaces only. Changing ion size, object size has very small effect on the percentage of atom of the surface. Very small effect on the percentage of atoms of the surface. Here when you are considering the surface atoms, inside atoms are very more, so surface atoms are very less. But here you can see this has big effect on the percentage of atom on the surface. The more number of atoms are available in the outer surface. The melting point does not depend on the size. The melting point here the lower for smaller particle is lower for a smaller particle. When the size is small, it has the lower melting point. Okay, then electrical properties, conductivity of the nanotube. Nanotubes are long, thin cylinders of carbon. I am going to consider as nanotubes. Example, this nanotube is very long, thin cylinders of carbon. The electrical properties change with the diameter, twist, and number of volts. That is a very important point. Okay, they can be either conducting or semiconducting their behavior, the electrical behavior. Next, electrical properties reaction rate is depending upon the nanoparticles are very small. When they are very small in size, then we are having very high surface area to volume ratio. Reactions are very quick. These reactions are very quick. These two properties are very important properties for chemical properties, not electrical properties, chemical properties.